The planetary gearbox is a highly efficient and compact way of transmitting motion. But how does this planetary gear actually work? What are the advantages compared to other gearboxes? And what are the fields of application? In this video, we will take a closer look at these questions, so sit back and enjoy the show. A planetary gear motor is an integrated system that combines an electric motor, or a combustion engine in some cases, with a planetary gear train. The purpose is to reduce the motor's high speed and multiply the torque. Thus, it provides controlled and powerful motion to the output shaft. Let's see together how this is achieved. A planetary gear motor consists of several basic components, but overall it works quite simply. The first part is the motor. We can use different types of motors here, such as asynchronous, brushless, or DC motors. The motor's task is to convert electrical energy into mechanical energy. The only additional component of the motor is a fan mounted on its shaft. However, this plays an essential role in the proper functioning of the entire system. We will discuss this later in more detail. The next step is to connect the motor to the gearbox. Both components are usually directly connected via the motor shaft and the first stage of the gearbox. This connection is either made directly by a coupling or by internal gear teeth. In this way, the high-speed, low-torque rotation of the motor is transferred to the first stage of the gearbox. The heart of the planetary gearbox is the so-called planetary gear train. This type of gear consists of three main components. The first one is the sun gear. It is mounted coaxially with the motor shaft and receives rotation directly from it. The second element is the planet gears. These are several small gears arranged around the sun gear. They are free to move in an orbit-like motion. The planet gears are held in place by a planet carrier, which is attached to the gearbox housing. This means that the planet carrier is static. The third and last important component is the ring gear. This is an internally toothed ring that surrounds the planet gears. It is fixed to the gearbox housing and therefore remains stationary. The individual components of the planetary gear are now working together to achieve a specific function. The sun gear rotates and drives the planet gears. These, in turn, roll along the fixed ring gear while rotating. This rotational and orbital motion is collected by the planet carrier, which thus becomes the actual driven element. By using this principle, the planetary gear is able to reduce the rotational speed and increase the torque. The speed reduction is determined by the number of teeth of the individual gears. If we compare the number of teeth of the sun gear with that of the ring gear, we obtain the so-called ideal reduction. The actual reduction achieved is slightly lower due to internal friction within the gearbox. The great advantage of this gear is that the individual gears mesh with each other over a large area. This results in high torsional stiffness and low backlash. The epicyclic gear is also characterized by its compactness. Several gears work in parallel, which distributes the loads optimally and ensures high resistance to high stresses. Let's now assume that we want to reduce the speed even further. This is easily possible thanks to the modular design of the planetary gear. To this end, we simply add another planetary gear train after the first. The output of the first planet carrier then serves as the sun gear of the second stage, and so on. In this way, we can combine several stages in series to achieve very high reduction ratios in a limited space. As already mentioned at the beginning, the heart of the planetary gearbox is the planetary gear train. However, there is still one component missing in this description, namely the output shaft. This is connected to the planet carrier of the last stage, which transfers the reduced rotation and increased torque to the load. This can, for example, be wheels, conveyor belts, or industrial actuators. The output shaft can be designed in various ways depending on the application. In detail, we distinguish between the solid shaft, hollow shaft, and flanged shaft. Depending on the requirements, the output shaft can be equipped with flexible or rigid couplings to connect to the respective actuator. To sum up, we can say that the planetary gearbox consists of the motor with integrated fan, the planetary gear system, and the output shaft. All components are perfectly coordinated and form an efficient unit. The motor converts electrical energy into mechanical energy, which is then processed by the planetary gear system. Finally, the output shaft supplies the required rotation and torque to the load. You might wonder why we need a fan when the motor itself has one. As mentioned earlier, the motor produces mechanical energy from electrical energy. This process is always accompanied by heat generation. If no measures are taken to dissipate this heat, it will accumulate in the motor and lead to overheating. To prevent this, we use the motor fan, which sucks in air from the environment and uses it to cool the motor. The air flows through the housing fins and removes the heat from the motor. Once cooled, the air is discharged back into the environment. But what exactly makes the planetary gearbox special, and why is it used in many areas? In fact, there are several factors that make the planetary gearbox particularly interesting. First, it offers high torque density in small volumes. This means that we can achieve high torques even with small gearboxes. This is particularly advantageous in applications where space is limited. Another important advantage is the uniform load distribution on the planetary gears. This results in high load capacity and long service life. The high efficiency of up to 97 per stage is another positive aspect. This means that only minimal energy losses occur in the gearbox, which is particularly important in drive systems where high efficiency is required. In addition, the planetary gearbox is extremely compact and coaxial. This means that the input and output shafts are located on the same axis, which simplifies the overall design. This feature is particularly advantageous in applications where space is limited and the axes must be aligned. The modular design of the planetary gearboxes also offers great flexibility. You can easily add multiple stages to achieve the desired reduction ratio. This also allows you to adjust the gearbox to changing requirements. So much about the basic functions and advantages of the planetary gearbox. But what are the typical applications for this type of gearbox? Planetary gearboxes are used wherever a high torque at the output shaft is required. This is typically the case in robotics, where precise and controlled movements are required. In addition, planetary gearboxes are used in the automotive industry, for example, for power steering, or in the aerospace industry, for antenna drive systems. Other applications include machine tools, conveyor systems, and actuators. We hope that we were able to provide you with a brief overview of the planetary gear and show you its importance in drive technology. Thank you for watching. We wish you all the best and look forward to your comments. Until next time.